This is a perfect equilateral triangle. Remember, equilateral triangles have 60-degree angles. Alright, so there's a perfect equilateral triangle. So let's start at the vertex angle, that's the angle at the top, and bisect the triangle. And I just created for myself two 30, 60, 90 triangles. Because when I bisected that side, it made each one of these one. Anybody remember what the height of a bisected equilateral triangle is? Or a 30, 60, 90? Anybody remember what the other leg is?
Where did he go?
This is 1, hypotenuse is 2, and the long leg is square root of 3. We could have found it just in the Pythagorean theorem, but take my word for it, it is. All right, so what we're going to do is we're going to find all of the 6 trig functions for the 30-degree angle. So let's find those first. So I'm going to do sine of 30, cosine of 30, and tangent of 30. And not the ones that I put in my calculator. I don't want decimal answers. I want exact answers. So I'm going to use my 30, 60, 90 triangle. If I'm standing at the 30-degree angle, sine is opposite over hypotenuse, so sine is 1/2. Cosine is adjacent over hypotenuse, so it's square root 3 over 2. Tangent is opposite over adjacent, so it's 1 over the square root of 3, which I have to rationalize. Then we can flip those over and get our reciprocals. Cosecant of 30 is going to be 2. Secant of 30. I got to rationalize. So I got 2 square over square root of 3. 2 square root 3 over 3. And then cotangent is square root 3. Good. All right, so now we want to do the same thing for our 60-degree angle. You can look at your triangle and do them that way if you want to, or you can use your cofunction identities and find them that way. All right, so that's our first special triangle. Anybody remember the other special triangle? Bless you. Our other special triangle is a 45, 45, 90. We'll pretend that's perfect. 45, 45, 90s are isosceles, and their legs are 1 and 1. The hypotenuse is the square root of 2. So if we're going to find the 6 trig functions for our 45-degree angle. So it's 1 over the square root of 2. After you rationalize it, it's square root 2 over 2.
because it's isosceles, your cosine and your sine end up being the same.